Hi all, today's topic is continuous distribution. Under continuous distribution, we have two types, exponential distribution and normal distribution. The derivation today. So the derivation in this video, derive moment generating function for a exponential distribution and find its mean and variance. We have to derive moment generating function for an exponential distribution and find its mean and variance. First step, so everyone know that what is exponential distribution formula. So f of x, so we are using continuous distribution, so f of x only we have to write it. F of x is nothing but lambda e to the power minus lambda x, where x greater than or equal to 0. So is my exponential distribution formula. This you can refer in this unit, the first video, formula video, you can check. Okay. So moment generating function for a continuous random variable, everyone know it is nothing but mx of t or m of t. It's integral over, I can write it in any three way. M of t is nothing over integral over minus infinity to infinity e to the power tx f of x dx. F of x now we know it is an exponential distribution, that I need to substitute it. So limit is given to be x greater than or equal to 0. Now change the question 0 to infinity e to the power tx as it is. F of x we have to substitute this. So lambda into e to the power minus lambda x. Both are exponential function. You combine this, both we have to combine it. So lambda is a constant. I will take it outside. So when I combine, so e to the power, always remember when it is an exponential function, you take the minus symbol first term. Okay. So reason e to the power minus x, when I write it, x can be taken outside. So lambda minus t into x. After writing this, you cross check it. So you multiply and you check e to the power minus lambda x, correct. E to the power minus minus plus tx. So it's correct. Okay. So like this you have to cross check. Minus of you have to write. The reason, when I substitute e to the power minus infinity, it's 0. But e to the power infinity, it is infinity. So I cannot, when I write it positive, I am not taking the minus symbol, means I have to write e to the power infinity. I will be getting the infinity only, infinity by any term infinity only. I will not get the exact answer. So that is the reason, always when you have infinity or exponential function, we have to write it minus of that term. When you write it, it is easy to substitute my upper limit and lower limit. So that is the reason we write it this way. Now we integrate it this. So when I integrate it, lambda is a constant, e to the power anything integration, e to the power as it is, divided by the corresponding term minus lambda minus t is the corresponding term. Substitute 0 to infinity is substituted. E to the power minus infinity 0. E to the power lower limit e to the power 0, it's 1, minus minus plus. So lambda divided by lambda minus t is my answer, moment generating function. So m x of t, we got the answer to be lambda divided by lambda minus t is my answer. So it is not fully completed. We have to do mean and variance also, we have to do it. So it's easy to find mean and variance. Moment generating function, one time differentiation with respect to t and put t equal to 0, we will get the first moment. That only I am going to do it. So e of x is nothing but differentiate with respect to t moment generating function one time and put equal to 0. I will get my first moment. Same in e of x squared. So 2 time differentiation with respect to t and put t equal to 0. I will get my second moment. So first moment when I do it, e of x, so differentiation I have to do it, differentiation you do it. So lambda is a constant. So this we can write it as lambda. So lambda minus t the whole power minus, and I will write it is easy for my differentiation. Minus 1 into lambda minus t the whole power minus 2 into inside function. So minus 1. So minus minus plus. Now put t equal to 0 in this. T equal to 0 means this is 0. So minus minus plus already one lambda. So lambda divided by this is lambda power minus 2. So lambda squared. So when it get cancelled, I'll be getting 1 by lambda. My mean is nothing but 1 by lambda. So what is my mean? 1 by lambda. So mean completed. E of x squared same way I have to calculate it. So same procedure. One more time I will do. Already one time differentiation this I have it. That one more time if I do I will get my. So before that you write it in a simplified form that it's nothing but minus minus plus lambda is a constant. So lambda is a constant. One time differentiation that term you write it like this. So it is easy for my calculation. E to the power minus t. One more time I have to do it. So now lambda is a constant. When I do one more time, minus 2 into lambda minus t the whole power minus 3 into again one more minus symbol. So now put t equal to 0 in this. T equal to 0 minus minus plus. So 2 lambda divided by lambda cube. Lambda cube. It's 2 by lambda squared. I am getting the answer. E of x squared. I am getting the answer to be 2 by lambda squared. Variance I need to calculate. Variance of x is nothing but e of x squared minus e of x whole squared. So it is nothing but 2 by lambda squared minus 1 by lambda squared. So it is 1 by lambda squared. So my variance answer is 1 by lambda square. So mean calculated, variance calculated. So completed. Derivation has been completed. Till here is a derivation. So now one additional information. It's nothing that that is exponential distribution has a memoryless property. So this we have to prove it. Memoryless property of an exponential distribution we have to. They may ask in the derivation cases. So if it is asked as a derivation, memoryless property for derive memoryless property of exponential distribution. So the derivation derive. So memoryless property of exponential distribution means how to derive it means first we have to write the statement. So what is the statement means? A non-negative random variable. Non-negative means negative should not be there. Okay, so it is applicable only for a random variable. Negative variable we cannot apply it. Non-negative random variable is a memoryless if probability of x is greater than s plus t, x greater than t equal to probability of x is greater than s. Okay. For all s t greater than 0. Okay. This is our statement. So this is the statement. So proof. So it's easy proof wise. Only that question we have to remember like a formula. You have to remember it. The proofs will be easy. How it is easy means first step you have to write f of x. F of x is nothing but exponential distribution formula. F of x lambda e to the power minus lambda x where x greater than or equal to 0. Now I will take only this x greater than s plus t or x greater than t. Okay, so I will not take the same variable. I will take some other variable and replace it. Finally, I will replace it. So I will take some question. Probability of x greater than, I will take some other variable m. Okay, this only I am writing. Okay, greater than t I will not take. Okay, after final answer I will change it. That is easy for me. So it's greater than m means how you have to write. Always it's rule greater means less. Okay, greater means whatever the corresponding variable it is greater than m means it the lower limit is m. If less than whatever the variable less than n means that is upper limit is n. Remaining limit should be followed with the question. For example, m means the question is 0 to infinity. So upper limit is infinity. Here it is a lower limit followed with the question it is 0. So this is the case we have to write it. Now it's greater than m means we have to write m to infinity f of x dx. F of x is given in the question. It's a Poisson distribution. Lambda into e to the power minus lambda x dx. Integrate it, you get one answer. Lambda is a constant. E to the power minus lambda x is e to the power minus lambda x divided by minus lambda. So substitute the upper limit and lower limit. E to the power minus limit is 0. So minus of lower limit minus minus plus this lambda get cancelled. So I will be getting e to the power of which I have to substitute for x minus lambda m. Okay. When I have x greater than m, my answer is this you have it. Check when it is greater than m, I have only e to the power minus m. Okay. Now replace both. Okay. This separate. I'm going to write it. It's easy. Okay. That I will write it. So when it is probability of x greater than t means, okay, same thing I have to replace e lambda t. Correct? Same way s plus t means, so this is there. Okay, I have written. But in between I have a given condition. So that everyone know probability of A given B. The formula is probability of A intersection B divided by probability of B. This is called conditional probability. This is called name to be conditional probability. Okay. So when I write it, according to our question, probability of x greater than s plus t given greater than s equal to t is nothing but probability of x greater than s plus t intersection x greater than t divided by probability of x greater than t. Okay, this both intersection. Okay, intersection means you check it is more than s plus t. Okay, more than s plus t. Yes. Okay, and greater than t is nothing but it is greater than s plus t because t means next variable t I have it here. So my next term will be t plus s only. Correct? It goes on. Okay, so it is more than both are greater than means both will be greater than t s plus t only. So I can write it as probability of x is greater than s plus t in the numerator divided by denominator no change probability of x greater than t. So now both I know I am going to substitute. Numerator I know, denominator it is here from the equation 1. Okay, substitute from equation 1. So when I substitute it, e to the power minus lambda into s plus t divided by e to the power minus lambda t. Okay, this denominator comes to the numerator. Okay, when I comes to the numerator, it is e to the power minus lambda s plus t. Okay, minus becomes a plus. Okay, this correct? In this minus. minus, because minus symbol taken outside, so minus t. Now simplify it. That's no? Yes. T get cancelled. It is e to the power minus lambda s. E to the power same way. E to the power minus lambda s means I can write it as probability of x greater than s. You check right hand side. Left I have taken. Now right my solution it came. See here. Left I have taken. Right I got the answer. So I have proved. So it is nothing but probability of x greater than s plus t given s greater than t equal to probability of x greater than s. So we got the memoryless property. This is our memoryless property.